morning students. Chapter 7 System of Particles and Rotational Motion. In last lecture we have discussed about rolling motion on inclined plane, and for that we have obtained equation of velocity at bottom and acceleration parallel to slope. Now today's question is obtain equation of μs, that is coefficient of static friction, for object rolling down on inclined plane without slipping. Okay, but before that, remember, for linear motion, acceleration parallel to slope, acceleration parallel to slope, it is g sin theta. Okay, from chapter number 5 if you remember. And for rolling motion, acceleration parallel to slope is g sin theta upon 1 plus k square upon r square. Yes, we have obtained this equation yesterday. Now, it is obvious from equation that this g sin theta is greater than this. Okay, means in rolling motion there is decrease in acceleration. So decrease in linear acceleration in rolling motion is equal to, decrease means it is greater than this. So how to find decrease? Obviously it is g sin theta minus g sin theta upon 1 plus k square upon r square. It is 1 plus k square upon r square. Clear about this? Now we have to simplify this. Okay, again how to find decrease? This minus this. Okay, g sin theta common, so it is g sin theta common. Minus, common, so it is common. So here it is only 1 minus, here it is 1 upon 1 plus k square upon r square. Any doubt? Okay, so now how to write? See carefully, okay, here. Okay, yes, here, how to write it is equal to, it is g sin theta here 1 minus, how to simplify this? See denominator, r square into 1 means r square plus k square. So in denominator it is r square plus k square, and this r square we have to write in numerator. Simple. So it is simplified. Now again g sin theta, how to simplify this? R square plus k square into 1 means r square plus k square into 1 minus r square divided by, in denominator it is r square plus k square, r square cut. So is equal to, it is g sin theta in bracket you have k square upon r square plus k square. Simple. So yes, first of all, for a linear motion, acceleration parallel to slope, g sin theta. For rolling motion, acceleration parallel to slope, g sin theta upon 1 plus k square upon r square. Decrease in linear acceleration, that is g sin theta minus g sin theta upon 1 plus k square upon r square, and it is equation. Now we know that this decrease in acceleration is due to frictional force. Okay, a decrease in acceleration is due to friction force, and therefore object rolls without slipping, Clear about this? So see, this decrease in acceleration is due to frictional force. Then what is frictional force? Therefore, friction force F is equal to, force is equal to mass into acceleration. Yes, mass into acceleration. So I have to just multiply mass. mg sin theta in bracket, it is k square upon r square plus k square. Simple. Okay, you have to multiply on the mass with this. So friction force F is equal to, it is mg sin theta k square upon r square plus k square. Now, if it is slow, angle theta, object is rolling down, mg is always vertically downward. Okay, here it is mg cos theta, and here it is normal reaction. Yes, you know that. Yes, you know that. Okay. Now, object is rolling down on inclined plane parallel to slope like this. It is not performing any motion perpendicular to slope. So, for perpendicular to slope, you can easily write n is equal to mg cos theta. Yes or no? Yes. For this perpendicular to slope, n is equal to, it is mg cos theta. Now you have to take that ratio because we know that mu s is equal to f upon n. Remember from chapter number 5, mu s is equal to, it is f upon n. Mu s is equal to, it is f upon n. Clear? So how to find this mu s is equal to f upon n? See, here it is. Put value of f, put value of n, and then you have to simplify, How to simplify? See, here I write mu s is equal to, what is value of f? mg sin theta in bracket, it is k square upon r square plus k square divided by, it is mg cos theta. mg cut, sin theta upon cos theta, it is tan theta. So therefore mu s is equal to, it is tan theta in bracket, here it is k square upon r square plus k square. So it is equation of mu s. It is equation of mu s. Clear about this? So yes, you have to remember this equation of mu s. Mu s is equal to tan theta k square upon r square plus k square. And yes, one condition you have to remember. Okay, condition for object. What is condition? If mu s is greater than or equal to tan theta bracket k square upon r square plus r square, then it rolls down without slipping. Clear? Otherwise it will slip. If this condition satisfies, then it is rolling without slipping. If this condition fails, it will slip. Okay, so yes, you have to remember this condition. Now, again, it is general equation. So, how to put values in general equation? If you are given one object that is thin ring, So for this thin ring, we know that radius of gyration K is equal to R. So put here K is equal to R, here and here K is equal to R. So mu s is greater than or equal to tan theta in bracket R square upon R square plus R square. Now see, R square upon 2R square. So R square cut, so it is only 1 by 2. So mu s is greater than or equal to 1 by 2 tan theta. It means if you are given angle theta, you are given coefficient of friction. If mu s is greater than or equal to 1 by 2 tan theta, then ring rolls down without slipping. Otherwise, ring will slip. Simple. Clear about this? Okay. So again, it is one important question, which is how to find coefficient of static friction between object rolling and inclined plane. Okay. So yes, in rolling motion, first of all, equation of V, that is velocity at bottom, acceleration parallel to slope, and this equation of mu s. These three are general equations for a different object, you have to just put value of a, that is radius of gyration from that table. Clear about this? This is it for today.